Okay guys, one last problem from 3.1. Convert negative 4x squared minus 32x minus 60 into vertex form by completing the square. Give the vertex axis of symmetry, domain, range, maximum, min, intervals in which the function is increasing and decreasing, and graph. So do all the things. Okay, so we're going to do this one by completing the square, even though I showed you the trick on the last problem. We'll do it by completing the square. So we have f of x. We're going to add the 60. It's negative 4x squared minus 32x. I also need to get rid of a, so I'm going to divide by negative 4. So that means f of x plus 60 over negative 4 plus x squared plus 8x plus blank. Okay, so how are we going to work this? Divide the 8 by 2. 8 over 2 is 4. And square it, which is 16. Now remember, if I add 16 to this side, I'm also adding 16 to this side. This is kind of bad form, but it's okay. This is now x plus 4 squared. So now I need to move everything back to the other side to get f of x back by itself. So I need to subtract 16 first. So we have f of x plus 60 all over negative 4 equals x plus 4 squared minus 16. Now I need to multiply by negative 4. F of x plus 60 equals negative 4 times x plus 4 squared. Remember, the negative 4 is also going to hit this negative 16 now. So 16 times 4 is 64. So this is actually plus 64. Subtract 60 to get f of x equals negative 4 times x plus 4 squared plus 4. A lot of different 4s on this problem. So now I can use this to find my features. I know my vertex is negative 4, 4. Axis of symmetry, x equals negative 4. It's the x value of our vertex. Domain, again, you should always get this right. It's negative infinity to infinity on every quadratic. Range. This negative 4 means it's opening downward. So that means my y value here is a maximum, which means it's the second part of my interval, and it has to go from negative infinity to 4 because it's going downward. It has a maximum of 4 at x equals negative 4. Increasing, decreasing. Remember, this is a downward facing parabola, so it's increasing on the left of our x value of the vertex. So it's increasing from negative infinity until we hit the negative 4, the x value of the vertex, and it's decreasing after that. So the only thing we have left to do is make a table. We know we've got the point negative 4, 4. I can plot that. Let's try plugging in a point nearby. Let's plug in negative 3. I'm going to plug it into the factor version, or the vertex form version. Negative 4 times negative 3 plus 4 squared plus 4. It's negative 4 times 1 squared plus 4. That's negative 4 plus 4, which is 0. So we've got the point negative 3, 0. Which means also by symmetry we have negative 5, 0. Is anything happening on the right of the vertex is happening on the left. One more point, f of negative 2. Negative 4 times negative 2 plus 4 squared plus 4. It's negative 4 times 2 squared plus 4. That's 4. So this is negative 4 times 4, which is negative 16 plus 4, which is negative 12. That's off the graph. Negative 2, negative 12. Just barely, but it is. That means we also have negative 6 and negative 12. Because of the negative 4, it's a big stretch, which is why this parabola looks so stretched. Goes all the way down. Try your arrow on both sides. And that's the graph. So these are all the features of the graph. Now, you don't have to necessarily complete the square. Like I said, if you find the vertex using x equals negative b over 2a, you can still generate the equation. Because again, a negative 4 here is the same as the negative 4 here, same a. But this is all for 3.1, and this is the last of the material on your second test.